right, so writing an equation in slope-intercept form. Again, we know the slope-intercept form is y is equal to mx plus b. We know that x and y represent any coordinate on the line. M is our slope, and b is our y-intercept. And that's why it's so creatively named slope-intercept form, because it gives you the slope and the intercept. This right here is in slope-intercept form. We can recognize that the slope is 2 and the y-intercept is -1. That means the line is going through the y-axis at 0, -1. Over here, this is not in slope-intercept form. This is not in the form of y equals mx plus b. But it could be. Alright? The benefit of having it in slope-intercept form is you can quickly identify the slope and the y-intercept, and you can graph it. Alright? If it is not in slope-intercept form, like over here, we can't figure out what the slope is right away, we don't know what the intercept is right away, and we cannot graph it right away. The benefit is we can put it into slope-intercept form. So you can write a given equation in slope-intercept form by solving for y, okay, in terms of x. So what does that mean? We're going to isolate y by subtracting 2x on both sides of the equation. Now on the left side it's pretty simple. We're just canceling out this term, and we're isolating y alone. On the right side, we have a positive 1 and a negative 2x. Those are not like terms. I cannot combine them, right? 1 is a constant. Negative 2x is a variable expression. You can write it in any order. Technically, you could write y equals 1 minus 2x. But we really want to have the variable expression be first, okay? So that negative sign goes with it. It's a package deal. We've talked about that. So it's negative 2x plus 1. Slope-intercept form is now set, right? We know that our slope is negative 2. We know our y-intercept is positive 1. And if we really wanted to graph this, we would be able to. Let's look at one more problem. I'm going to do this first one with you. We want to solve for y. Sometimes it's even called the literal equation when they ask you to solve for an exact variable. We want to get y alone, because again, we want our answer to be in the form of y equals mx plus b. Let me state, it is okay if m is a fraction, or even if b is a fraction. That is sometimes possible. Remember, m is usually a fraction, the slope is usually a fraction, and if it's a whole number, we want to put it as a fraction, whether it's improper or proper. Okay, so we're going to solve number 1 for y. First thing I'm going to do is subtract 3x from each side. On the left side, the 3x cancels out. I'm going to bring down this 2y. On the right side, I have a positive 6 as a term and a negative 3y as a term. I want to write the variable expression first, so I'm going to write negative 3x. The negative sign stays with the 3x. The 6 is positive, so I'm going to write plus 6. If the 6 was negative, you'd write minus 6. So now I have a new equation. It's 2y equals negative 3x plus 6. The last problem we were done already, but that's because we had y isolated. We do not have y isolated here. We now need to divide everything by 2. And when I mean everything, I mean everything. Okay? Every term we see is being divided by 2. This cancels out, leaving us with just y. I now have negative 3 over 2 x, and then plus 3. 6 divided by 2 is 3. Negative 3 over 2 just stays as negative 3 over 2. This would be our equation in slope-intercept form. We'd be able to graph this. The slope is negative 3 over 2. The y-intercept is positive 3. Okay, let's finish this off by actually graphing this problem, okay? Alright, so I have my coordinate plane. Remember, this is the x-axis, this is the y-axis. Our equation is y equals negative 3 over 2x plus 3. Alright? To graph this, we start with our intercept. B comes before m, right? our b is positive 3. So that means on the y-axis, I'm going to determine where positive 3 is, right? The origin is right here. So I start there and I go up 3 units. Bam. There's our y-intercept. Our line is going to go through that point. Now our slope, our m, is negative 3 over 2. Okay? The numerator tells us to move up or down. Because it's negative, we're going to move down 3 units. The denominator tells us to move left or right. Because it's positive, I'm going to move right. I know that my line needs to be going downward once I make it from left to right with a negative slope. So I'm going to go down 3 from the y-intercept, right, from right here. So I go down 3 and to the right 2. And I make a point there. I can go down 3 to the right 2. The other thing we could do is, let's say you didn't have enough room. Maybe the paper, ran out. Maybe we could only go to the left to make that point. That's still possible. Okay, that is still possible. You can move the slope in the complete opposite way. Instead of moving down and to the right, we could technically move up and to the left. And it'll still stay on that same line. From the y-intercept, I can go up 3 units and to the right 2. Okay? And that's true for any point. I even went here, if you go up 3 and to the left 2, up 3 to the left 2, that's basically like having 3 over negative 2. It's the same thing. The last step is to just draw a line through all of these points. Okay? And you should always extend it a little bit past those points and draw the arrows at the end because it's infinitely growing in each direction.